Alright, so just a quick little video today on the existence of solutions. Okay, so far when we were looking through solving systems of matrices, or solving systems of linear equations using matrices, pretty much every time we got an answer. Okay, however, that doesn't actually have to be the case. Just because you've set up a beautiful system of linear equations does not mean that that simultaneous set of has a solution. Okay? You would have seen this a few years back when you were looking at how lines can intersect. But they can either intersect once, just run into each other. They could run parallel and on top of each other, so they're actually intersecting everywhere physically possible. Or they could be parallel and not on top of each other, and then in that case there'd be no set of solutions. In this case, we see the set where there's an infinite number of solutions, and where there's no solution as pretty much the same thing. Okay, so our goal is to just get one answer. Okay, so we may not always be able to solve a system of equations we have set up to get a single answer. And that's, again, what we do want. So here's a little tutorial on how we can check and what we're really looking for in some terminology. Okay, so here our key idea is that if the inverse of the square matrix, so this is the one that you've set up using the coefficients, okay, so the square matrix of coefficients does not exist. Okay, so if the inverse of the square matrix does not exist, then there is no unique solution to this system of equations. Okay? So in reality, what that really means for us, so the actual significance, so for AX is equal to B, okay, where A is your matrix of coefficients, X is your matrix of unknowns, and B is your matrix of constants. Okay, if det of A, so if the determinant of A is equal to 0, there is no unique solution. Again, I'm using specific terminology here. I'm not just saying there is no answer. The specific terminology is there is no unique solution. So just a quick note on a couple of terms that you'll be expected to know and use. Okay. In particular, this idea of no unique solution. Okay. So that's what we mean when there's not a single answer. So again, this can either be the situation where the lines intersect everywhere and there's actually an infinite number of solutions, i.e. there's no unique single solution, or where there just isn't a solution at all. We group those together as no unique solution. Okay, so we say no unique solution, or that A is a singular matrix. So this is when we have either an infinite or no solution at all. Okay. Otherwise, if there's no unique solution, the only other option is for there to be a unique solution. Okay. So we say a unique solution, or that A is a non-singular matrix. Okay, so a single point of intersection is really, if you're thinking back graphically, what would happen with the 2 or 3 or more lines that you have gotten. So that's the terminology. In a separate video, we'll do a few examples.